the 15 years preceding Darwin's publication of The Origin of Species and Alfred Russel Wallace's paper to the Royal Society in London, all of biology in England and Germany and on the continent, all of biology was intensely involved with what the literature of the time called the problem of the species. And, all these people were exploring various parts of the world, especially the tropics. They could see that if you go from one Indonesian island to another, there is shift of species, there are slightly modified forms. In other words, they had all the ingredients in front of them on the table, and people were trying to figure it out, but they didn't quite have it. And then it crystallized in the minds of certain people.
Well, I figured it was about time I made a video regarding the Temporal Compendium, what it is, why I made it, what you guys can use it for. Really what this is, it's a collection of academic papers which I have slowly, over the course of the last decade, curated and put together. It's not every paper I've read, it's only the ones that I felt were a part of the mosaic or the jigsaw puzzle, so to speak. For those of you who aren't familiar with me and my story, hi, I'm Dan. I'm an independent researcher, normally loosely affiliated with the APEC Advanced Propulsion and Engineering Conference. And I had a multiple witness UFO encounter over a decade ago that kind of set me down this path, and I don't know, I don't want to say it gave me a download because that's too fucking cliche, excuse my French, but it made me curious and to keep an open mind. And as I started going and studying physics and reading these papers, most of them were bullshit, but every now and again I'd see one of them, there would be just something in the back of my head that would tell me this is a piece of the puzzle, so to speak. And over time I eventually came into contact with a Dr. Tim Taylor, and I started showing him just some of the papers that I had been collecting over the years, because he was the first PhD physicist to really give me the time of day. And he started going through the papers I was showing him. He said to me, this I see a lot of overlap with my existing work. If you haven't already, you should really think about putting this, codifying this into one place that's easy for people to find altogether. And so that's what I did, starting probably like 4 or 5 years ago. As I started not just taking the papers that I had, I started going through and figure out, what goes into what volume, what goes where, and I started seeing that there was I don't want to say a story crystallizing here, but there was something. And if you know anything about the compendium, you know where this is going. But I just figured I would kind of take you guys through the first few volumes, so to speak. And I'll probably end up doing videos on each individual paper, so to speak. But it starts with volume 1, which basically, you could think of this as like the introductory binder or piece to the rest of it. It kind of lays out partially the motivation, but also the tidbits that will be explored in greater detail in the subsequent volumes. And so, what is this idea that I'm getting towards? It's that warp drives can be used as time machines, which can be used as multiversal devices. Sounds crazy, but if you're here watching this, I mean, like, there's probably a reason for it. Whether or not it's a valid one, that's up to you. But I start with I'll just take you through some of the high bits of some of the papers. Starting with the first paper in this, it's the Theory of the Universal Wave Function and the Origins of the Cosmos by Maya Benowitz. And in her closing remarks, she says, if quantum universality is true and the multiverse exists, there must exist worlds where future humans master the quantum nature of space-time and travel to past adjacent light cones, a form of time travel in the multiverse. But if this were possible, then where are they? Obviously, that invokes Feynman and the Fermi paradox, and I might be conflating a couple names there. Anyways, right after this, it goes into Hal Puthoff's ultra-terrestrial models, which opens up with the statement that there is an unidentified phenomena interacting with the current human population of Earth. It is currently unknown whether the phenomenon is exclusively extraterrestrial, extra-dimensional, crypto-terrestrial, demonic, jinn, proto-ancient human, time travelers, etc., or some combination or mutation of all of these. However, it appears highly likely that the phenomenon per se is not constituted exclusively of members of the current human population. And then, if you can go through and read the rest of his paper, but it just kind of plays off nicely of the ending, the closing statements of Benowitz of where are they? And then there's a phenomenon interacting with the human population of Earth. And then there I go into the executive summary of the 2004 Nimitz encounter, because it's our best case that everyone can point to as there's some kind of there. And without going through the executive report, we then go to Estimating Flight Characteristics of Anomalous Unidentified Aerial Vehicles by Dr. Kevin Knuth. Excuse me. This should be a paper that is familiar to many of you. If it is not, go read it. Among it, they go into the estimations of various UAP encounters, including the Nimitz incident, and this is where the 5,000 Gs number comes from. And he basically goes into how these things could be used as spacecraft, just off the speeds we see them doing within atmosphere and the amount of Gs in which they're able to accelerate. At a 5,000 G acceleration, which the 2004 Tic Tac portrayed, it would only take you on the order of roughly an hour and a half to reach light speed relative to your departing destination, which is rather profound when you start thinking about some of the consequences that that might entail. And then from there, let's see, my version, I put another paper in here that won't be on the digitized version, which, by the way, there's a digitized version uploaded to Zenodo. All copyright rights have been refused because, again, this is a compilation of existing papers, so nothing should be violated there, and even then compilations are protected under U.S. law. And then it goes into the Lectures in UFO UAP Metric Engineering Physics by Dr. Jack Sarfati from August 2022, where he kind of goes through and says the only mechanism that we know of within the known laws of physics that would even allow for such as the 5 observables associated with UAPs and UFOs, or I guess now 6 observables, is that of an Alcubierre-esque style warp drive. And he starts going into some of the implications of it and how you can tilt light cones to overlap with past adjacent timelines, invoking some terminology that Benowitz had already used here. So we're seeing a converging of ideas. And going past Sarthadi, I mean, he makes a very, very very good case for this. So we start wondering, well, if we're going to take warp drive seriously, we should start taking the implications of what we know a warp drive can do seriously. And then that will lead us to Dr. Barak Shoshani and his series of papers starting in 2019 with his lectures on faster-than-light travel and time travel. And then it's in here where he starts going through and giving the actual the basis that readers will need to understand pretty much all the content going forward on how any system that can be used for relative faster-than-light travel, like a warp drive or wormholes, can be used for time travel. And then he starts going into some of the implications of that, and then he has a series of papers, about this thick. I mean, that's not an insubstantial amount of material, where he basically goes through and builds the case that if time travel is possible, it has to exist within the context of Everett's many worlds, for various reasons which you can find written out very well in these papers that are publicly online, and you can go find them yourselves. And he goes, and it's a series of iterative papers, and it ends on his paper on warp drives. Let's see, time travel paradox and entangled timelines. I'll go one more. Page 9. And here we are. Which is warp drives and closed timeline curves. And this is a very good introduction to what the compendium is. This is volume 1. From volume 1, I will close this. From volume 1, we then go into volume 2, which, now that we have established that we should be taking the idea of warp drives and many worlds and time machines seriously, we then go start building back on the ideas that Shoshani had laid out, and we jump back in with David Deutsch and the quantum physics of time travel, which, again, all this is here, and you can go find these online. I have them already compiled into the compendium volumes for you digitally, which I have, which I've mentioned before, and I will make sure to provide a link in the description for you guys to go check out. And so then going through, Deutsch just kind of reinforces a lot of what Shoshani says in the previous volume. And we can go through it, and eventually we get to a paper titled, let's see, we're still on Deutsch's stuff here. Oh, no, we're a little too far to Bekenstein. Oh, there's the paper we want. All right, this paper titled All Objects and Some Questions. And within it, he has this very beautiful diagram, and it shows, and again, I'll probably superimpose this and post at it so you guys can see it, and you're not having to try to zoom in on these pixels that you guys can't see. But up here in this corner, you'll notice the Hubble radius being the radius of the observable universe, and how it actually is on the black hole line. Okay, now I'm sure people are starting to ask, what the hell do black holes have to do with time travel in the multiverse? It gets into there, but this shows us that we can, at least within some respects, treat the observable universe as something analogous to a horizon-bound object like a black hole. The analogies aren't one-to-one. There's some inverse things going on here, and lots of caveats, which I'm sure people will be screaming in the comments, but trust me that I'm aware of them. But from here, we go into Bekenstein and his work on black hole entropy. And then from Bekenstein, we end up going into Ted Jacobson and his paper on thermodynamics of space-time, the Einstein field equation of state, where basically this becomes the foundation paper for many of the future subsequent works, most of which are included in Volume 2, discussing on how you can get general relativity as emergent from quantum systems via entanglement entropy, which kind of serves as the, I'm not going to keep saying justification a million times, but you guys are getting the point. And it goes and builds into Ted Jacobson's work, and I don't think I include Verlinde because he's kind of a toy model of this stuff, so to speak. Then we go into Sean Carroll in some of his lectures and papers, continuing these exact same ideas that were first put forth by Jacobson and such. And he starts going and showing on how you can get GR to emerge from the quantum wave function. Now, why this is important is because it pretty much sidesteps almost all of the problems with traditional quantum gravity and trying to unify the gravitational field with the standard model of particle physics. That itself is a whole other video, which you can find other people have already covered in relatively good detail, but all the papers as to which those videos will be based on you can find here. And he goes into things like branches of the black hole wave function need not contain firewalls. The black hole wave function we can think of as the universal wave function, because remember we established via all objects and some questions that we can treat the universe as analogous to a black hole. And if it's a quantum first system, it itself will have a wave function. And we finally, I think I put it in this one, though I may have moved around a couple times. Yeah, yes. Escape from a black hole with a spherical warp drive, where Dr. Yuri Eroshenko basically goes to introduce the WD equals EPR conjecture, where it's complementary to the ER equals EPR conjecture. Because remember, if every object within general relativity can be seen as a semi-classical approximation of some quantum system, or an emergent semi-classical approximation of a quantum system, then things like wormholes and warp drives will themselves be able to be described by some sort of entanglement system. Whether or not we have the computational capabilities to currently do that, that's a different conversation. But, you should be able to see where this is going. And so this says if you can use a warp drive to escape a black hole, essentially you can use a warp drive to escape the universe, or the local branch of the multiverse, so to speak. Now, this is where Volume 2 ends, and instead of going right into warp drives from here, we then go to Volume 3, which builds heavily on many of the ideas established in Volume 2. I actually included Schrodinger's on the meaning of wave mechanics. I forgot I included that, which that's a precursor to the many worlds interpretation. As whoever read it, Schrodinger gave a lecture in Dublin in I think 1951, where he basically says, this is what my equation is saying is happening, but I'm going to leave the proper derivations to future work, which ends up being where Hugh Everett comes in with the Everett interpretation. And then this just has quite a few different papers on justifications on why we might want to view the many worlds as the valid interpretation, especially for what we're doing. And eventually, as we go down it, it starts getting into not just building up space from entanglement, but also the Page-Wooters mechanism and getting time from it too. Because remember, it's not just, GR isn't just space, it's space-time, right? And then from there, we end up going into more of Maya Benowitz's work from the first paper of the first volume. I have some of her previous drafts that she's iterated on, and so you can see more justifications of why she makes the decisions that she does. And it ends up being a really good it ties together pretty much everything that's talked about in volumes 1 through the end of 3, and brings us to the justification now, finally again, of talking about warp drives in volume 4. So we will close this, grab volume 4 here, volume 4, which opens up with, I have a cover page showing what like the table of contents, basically, for each volume. And this opens up with Alcubierre's 1994 paper, The Warp Drive, Hyperfast Travel Within General Relativity. So we've already established that the multiverse is the right framework to be working in with this stuff. So now we have to understand, okay, what is a warp drive? How is it working? What is the literature on this? And we start with Alcubierre, even though he's an unphysical system. It's really a toy model, but he becomes the basis in which we build on. And he then goes to the Van den Broek warp drive, which is the multi-layer one. It's kind of bigger on the inside, like a TARDIS, funny enough. And then we go to warp drive with zero expansion by Jose Notario in 2002. Then we end up going into Dr. Harold Sonny White and his warp field mechanics 101 and 102. Again, he is somebody that you should be familiar with, as well as his world-line numerics applied to custom Casimir geometry generates unanticipated intersection with Alcubierre warp metric. And then eventually introducing physical warp drives by Bobrick and Martyr, and this starts going in and addressing the negative mass issue, which is notorious for being why Alcubierre is non-physical. And we go into quite a series of papers of not just Bobrick, but we also have Eric Lentz, we have the Fallon-Heisenberg model in here, just showing that there are multiple ways to skin this warp drive cat, and not all of them require the so-called negative energy, right? So this is very good. A very underrated paper, which will become clear as to why it might be important later, is warp drive aerodynamics, where he basically shows that an aerodynamic shaped warp drive, as counterintuitive as it seems, may actually be more efficient than other such models, depending on how you set up the axioms and what you're trying to do with it. Again, a bunch of caveats here. And then we end up going into the Warp Factory, which was made by the same team as Bobrick and Martyr, basically giving you tools on how to make your own simulated warp metrics using a MATLAB tool for future researchers to try and chip away at these energy requirements. And they have a series of papers, constant velocity, physical warp drive solutions. That was a longer paper. And getting back into arguably what I think is probably the most relevant or up-to-date or best version of the warp drive metric, at least up until this date, when this was written, was Dr. Travis Taylor's Modifications to the Alcubierre Warp Field Metric in Isotropic Matter and Implications to Detect Warp Fields, written for Radiance Technologies when he was working for them. And this is the paper where he basically extends the Van den Broek metric into, instead of a 2-layer warp shell, into an N-layer warp shell. And then he figured out, he's figuring out by adjusting the parameter thicknesses of each shell, and some other variables that go into this, we can actually drive the energy requirements down to roughly about a kilogram worth of mass energy for a luminal warp drive, which is the lowest that it's ever been. So the idea that we need planetary or stellar mass sizes in order to make a warp drive work is just, it's simply outdated. And Travis Taylor shows this again. And then from there, once you read Travis Taylor's paper, it starts getting into some of Harold Puthoff's stuff with his polarizable vacuum. and it being if it can be used for or the engineering of zero-point field for polarizable vacuum for interstellar flight by Dr. H.E. Puthoff. And this kind of shows that there is another lens to look at the warp drive through than just GR, i.e. this PV model, which brings us to the end of volume 4 and into volume 5. And we'll close this, grab volume 5, which again we start up with Hal Puthoff's polarizable vacuum representation of general relativity, because now that we know that the PV model can be used to think about warp drives in a sense that might be more friendly to electrical engineers, for example, it's probably a good idea to get people more familiar with the PV model, why it can be used as a representation of general relativity, not necessarily one-to-one, which I'm sure there are people who will argue with me on that because they have, but that is besides the point right now. So it goes from his PV paper to his DIRD that he wrote for OSAP, again, based in this stuff. Papers sticking together. The advanced space propulsion based on vacuum space-time metric engineering, where this was written initially for the OSAP, DIRD's Defense Intelligence Reference Documents, for the OSAP program, which Dr. James Lukaski said was one of the 2 most important papers that came out of that program in regards to the reverse engineering programs that they have going on. So now that we've, assuming you've read this, you're at least familiar with the idea of PV-style warp drives, we then go back to Dr. Jack Sarfati in his 2011 paper, Is Low-Power Warp Drive Possible? Which he pretty much starts saying, we don't have to look at just the vacuum, we can look at within matter, too, and how that will change the coupling constant, similar to how the PV model would. And this becomes the basis for a lot of the metamaterials, and actually this is one of the papers that Dr. Travis Taylor references in his paper that I have in volume 4 that we talked about just a minute ago. And it goes into a little bit of his stuff, as well as I ended up throwing it in Alonzo Serrano. I forgot I did that. The emergent time and time travel of quantum physics. Get through this. Kind of forget what I have where. One of Jose Rodal's comments on Sarfati's work, on the Sarfati's entangled entropy gravitation. And again, you guys will be able to read this, and at this point we get into the warp reactor concept by Lawrence Livermore, which is essentially using the ideas introduced by Jack. Pretty much saying, if we have if the plasma is within these warp reactors, they have a refractive index, which is not the same as the vacuum, so therefore the coupling constant should be different. This is a way that we can help with fusion. Again, for reasons which are all laid out quite clearly here, and then from here I end up going into, I believe, Dr. Sal Pais. Yes, yep. And his plasma compression fusion device enabling nuclear fusion ignition, which actually has many parallels with the Lawrence Livermore concept. Also his Superforce paper, which he also talks about a traversable multiverse in the conclusion. And going through Sal's papers, excuse me, if you know what you're looking at this point, you should be very clear that really what Pais has given us is a version of a warp drive, specifically a modified Vandenberg style, which we've you can find an interview with me and Dr. Peiss on this channel from about a year ago, at least from when this is being recorded, a little over a year ago. And it includes not just his patents, but also his papers, which personally I find to be better written than the patents, and a little bit more intellectually clear. And from there, he uses a lot of terminology that most people aren't familiar with, like Schwinger limits and various types of things. And so then we end up getting to the bifringence of the vacuum, which is very important to the ideas of vacuum polarizability. These ideas that are already being entertained by Puthoff, Peiss, Sarfati, et cetera, et cetera. So you get to learn about what vacuum bifringence is. And, this is important. The positron production by multiphoton light-by-light scattering, which is important for reasons that your brain will connect if you end up going through all this. Basically, if you can break the Schwinger limit, you're modifying space-time, and there you can get a warp drive out of that if you know how to tune everything right and not kill yourself in the radiation in the process. Again, all this is easier said than done, but the laws of physics don't disallow it. That's the important bit. Let's see. Acknowledgements. Measuring the boiling point of the vacuum of quantum electrodynamics, which is getting into specifically the Schwinger limit, the Schwinger effect, like discussed by Peiss. And then to get this back into our QED response to the vacuum, yep, this is all important stuff that you guys will need. And then it ends up getting into a mesoscopic Klein-Schwinger effect within graphene. Because remember, Peiss actually mentions that graphene is a candidate material to be used in place of some of the material, or I think it's in place of the PZT junction in his paper. Anyways, there ends up being quite a few different reasons that graphene becomes important for producing one of these ships. Essentially, if you can get a mesoscopic Klein-Schwinger effect in graphene up below the Schwinger limit, there's some things going on here which show that we should be able to engineer graphene in such a way where it becomes a candidate material for these Sarfati type metamaterials in order to when we make our warp drives. And so then from here we end up including quite a bit on graphene, superconductor versus insulator and twisted bilayer graphene. Depending on the angle of twist between the two different layers, you can get it to be a superconductor or an insulator, or all kinds of different weird properties depending on what the magic angle is set at. Mechanically bent graphene is an effective piezoelectric nanogenerator. Try to get through this. What's the next one? Let's see, charging capacitors. Strongly anisotropic media, the terahertz perspective on left-handed materials. This becomes relevant again back with Sarfati's work, and as well as the graphene. You, by this point, if you're not seeing a bunch of convergent lines of thoughts that are starting to line up as puzzle pieces that are fitting together, not necessarily from this video, but if you've actually gone and read all these papers yourselves, too, your brain will start making these connections. Parametric amplification of a superconducting plasma wave, which ends up bringing us to the superconducting plasma actuation by Andrew Blair of IO Aircraft. And get this to go over here because I have a lot of pages here and this doesn't work. I probably should. There's a lot of crayons in here. Anyways, and this kind of goes and shows that using all of the principles built up in here, there is at least a conceptual way to integrate them into an aerospace platform. Which, again, then starts bringing us, this will lead us directly into Volume 6. I will close this and grab Volume 6. So Volume 6 is the last one that I have digitized. I have a couple other volumes, but I don't have them organized yet because I don't really like how they it's kind of hard for me to fit them in here. I'm just, they're not as important as the 6 core volumes. It's more just context that's helped me. It will probably help you, and I'll get around to digitizing it eventually. But you have an observation of flow-cat states within graphene. If you've been paying attention to Dr. Jackson Fatty's work, you should know why that is very, very important. 16. Probing non-equilibrium topological order on a quantum processor. That actually has to do with some of the graphene and flow-cat states and ferrite condensates, which are important for reasons that are established in volume 5, and how graphene can be used for this stuff. Long-lived Valley states and bilayer graphene quantum dots, again, directly applicable to stuff in volume. So this is pretty much graphene continued from volume 5. Yeah, and it has quite a few different things here. Let's see, page 34. Try to get. Yeah, and then basically once I get through, this extra half dozen or so papers, continued from volume 5, discussing graphene, we get into the proposal and draft between myself and Dr. Chance Glenn, who again was his positive energy warp drive solutions were included in volume 4 of the compendium. And me and him, I basically gave him the idea that the plasmas naturally forming around a hypersonic plasma sheath are a candidate to be engineered to get a positive energy warp field. It fits the requirements that he needs. Now, it's not as strong yet. It needs to be pumped to fill the rest of the gap, but it gives us a starting point. And then from here, it goes into proper propagation characteristics of terahertz wave and a hypersonic plasma sheath. And it's a bunch of various papers mapping out all of the various characteristics of hypersonic plasma sheaths and how the existing technologies that the aerospace industry has been exploring for the last 20 years on ways that you can manipulate these plasma sheaths around these hypersonic crafts via, MHD and RF pumping, electrostatic fields. There's a whole bunch of different ways that we can do cool things with the plasma. Instead of just trying to mitigate the blackout, we can use it for performance enhancement, or aerodynamic performance enhancement, even before we start getting into any of the warpiness. But this will all end up being important and related to some of this stuff, especially if you want to make a safe warp drive that can double as an airplane in case the warp drive fails. It needs to be an effective, regular, conventional airplane. Now, it doesn't need to be an airplane to be a warp drive, but this is getting into safety regulations, and just because you can do something doesn't mean you should. Plasma-based hypersonic flow control, and this kind of shows that there is a way to do this conceptually. Like none of these technologies or ideas break the laws of physics. They're not science fiction. These are pieces of the puzzle that have existed in the public realm already for the last 15 or so years, but they are just now beginning to crystallize in such a way that people are able to start putting the pieces of the puzzle together. And that's exactly why I have compiled the compendium, is I wanted to make sure all of this seemingly separate information was in one place and together, where if viewed as a collective, it paints a mosaic of what type of future is possible if we get enough minds put to it. And so that's I guess this is about it for what the Temporal Compendium is. And the video is actually already longer than I initially anticipated it to be, so I will probably cut it off right about here. But yeah, so this is where you can find the tools to start educating yourselves to where we can work together in the future on this common idea to make the holy grail of science and engineering together, i.e., a warp drive. So I will link a digitized copy that has everything that I just showed you in the description for you guys. Go download, research, have fun with it. And yeah, if you guys have questions, feel free to throw them in the comments. I will do my best to read them. I'm not entirely sure the direction I'm going to be taking this channel in the future. You know, like I said, I might do individual videos on each paper. I don't know where I'm taking this yet. So if you guys have anything particular you want to see, or you have certain things that you want me to break down in more detail and why they are related to other such things in the compendium, like if you see two things in two different volumes and you're not sure why they're related, feel free to ask me a question and I will attempt to address it best I can. So have fun, guys.